Okay, so what we have is 8, it's basically 8 over 14 times 7 over 13. And then we take that answer and times it by 7 over 10 times 6 over 9. Because we're following the two boys' roots. And if we times those together, we get 28 over 195. Right. Oh, this looks fun. So we've got a set of positive integers less than 20, so 19 and below. Now, A, if we were to make this into a little thing, or even a Venn diagram as it's called, let's do that. So A is everything less than 12, okay? So that's fine. We can start putting in anything up to 7. So that's 1, 2, 3, 4, 5, 6. Now, B is anything less than 16 but greater and equal to 7. So we get 7, 8, 9, 10, 11 in that bit. And then 12, 13, 14, 15 and 16 in this bit. Now we should really put B and A in. No, I lie, that is not 16 because it's less than 16. Okay, don't love what I just did there. So that's 15. And then we get 16, 17, 18 and 19 on the outside. So list all the members of A intersection B, and this one means A and B, so anything that belongs to both sets. So that means the bit in the middle. So we've got, I'm going to use the nice things, and we're going to go 7, 8, 9, 10 and 11, and then we're going to use the little thing, and then we're going to put that in there. Right. C is a set such that C is a member of A and the numbers in C equal 3. So it basically means that it has to belong to this bit here. Okay? List the members of one possible set C. So they're all even numbers. So it means that you look into A and you say the numbers in A that could be in C are 2, 4, 6, and then we've actually listed 3, so that means that's the answer there, but you could also have 8 and 10, and that's your answer. It's quite nice. Right, use algebra to show the recurring decimal 0.254 with the dots on the 5 and 4 equals 14 over 55. So I always do this. So I do 0.254 and I write out what it's going to look like. So it's a repetitive 5 and 4, depending on where the dots are. So that means that whatever we do, we've got to make our little algebraic equation add up so that the 5 4s, we get rid of the 5 4s. So what we're going to say is that x equals 0.2545454, etc. And I want to get it so that my 5 4s are in a line there. So if I times by 10x, I get 2.545454, etc. But if I times by 100, it would throw everything out. So let me just show you what 100x would look like. It would be 25.4545. And so if I put that underneath it, it will give us a horrible number. And it won't be very useful, because the whole point about this is to line stuff up. So I'm going to times this by 1,000. I'm going to times x by 1,000. And what that's going to give me is 254 because that goes 1, 2, 3, 5, 4, 5, 4, 5, 4. Now, on this side, I get 990x, and then I get 252. See, it all lined up. It was terribly nice. And then we go x, and we divide both sides by 990. So x equals 252 over 990. Now I could go through and do lots of actual work, but I could just put it into my calculator now and find out that 252 over 990 equals 14 over 55, which is a relief, because sometimes, usually the mistake you make is you don't look very well at the dots up there. Okay, here are the first 5 terms of an arithmetic sequence. Find the sum of the first 100 terms of the sequence. Now, in order to do this, I really do need to know the thing at the front. So I need to know that sum of n equals n over 2, 2a plus n minus 1d. So we're going to go all the way down, having remembered that, which I don't think I have. Here we go. So here we go. So it means the sum of n equals n over 2 brackets. I really do need to learn this off by heart. I'm going to write this down outside of this experience. Hang on. So I'm just writing this on a piece of paper. So that's n over 2, 2a plus n minus 1d. There we go. Right, excuse my ineptitude. There we go. So it is 2a plus n minus 1 d. Right, next thing we need to know is these are the first 5 terms of an arithmetic sequence. So let's find out. So the first term, term 1, equals 7. Good. And now the difference between them is 3. So difference equals 3. And now we need to know the 100 terms. So it means the sum of 100 equals 100 over 2 times D, the difference. So I'm assuming that's the 99 times 3 at the end. And 2a would be 14. So 2 times 7 plus. Okay, so we've got 50, 14 plus whatever 99 times 3 is. 297 plus 14 equals 3, okay, and then that's 50 times 311, which equals 15